Hi everybody. You should have your Unit 7 notes out. Please make sure you're on the part that says 7.4a. So today we're going to use all the skills you guys have learned so far in this unit, how to factor and distinguishing between the two different kinds of factoring problems. And we're going to take it one step farther and actually solve equations. So this time we'll actually get an answer like x equals 5. The first thing we need to talk about, though, is this zero product property. And you guys know, let's say I told you that 3 times x equals 0. You guys would be able to tell me, and you could actually solve it like this if you wanted to, divide both sides by 3, but you'd be able to tell me that x equals 0. So I know if two things are multiplied together and the result is 0, I know at least one of them has to equal 0. And that's what this zero property means. So this time, I know if I have a times b that equals 0, one of these two guys, either a or b, is going to have to equal 0 for that to be true. The other thing, quadratic equations, we've referred to this a lot. Quadratic, remember, means the highest exponent right there is 2. We've used that term a lot. You guys have been solving quadratic expressions when you factor. Really the difference here, though, this is called an equation because it has an equal sign in it. And notice it's going to equal 0. Here are the steps we're going to need to use today. So our first job, remember we're using equations now, so there will be an equal sign in it. We need to make sure the equation is equal to 0. So that might mean that you need to move all terms so they're on the same side. You guys don't have this part in your notes, the second part that's in parentheses. That would be a good thing to write down. So move everything to one side of the equal sign. Then, once we have all the terms on the same side, we're going to factor it. And this is the part that you guys already know because we've been spending the last several days working on the different ways to factor. So you might have to just pull out the GCF, or you might have to use the Xbox. And remember, you got that cheat sheet yesterday where it talks about, remember the question at the top said, is there a GCF? And then based on your answer, you went to the different set of directions. Then what we're going to do, once you factor it, we're going to take each factor and set it equal to 0, and then we're going to solve each mini problem that we have. Just a second. We're really on step 3. So it's already been factored. Step 2 is done. We're on step 3. We're going to set each factor equal to 0. So let's check out example 1. This one is already factored. I can tell because I have two sets of parentheses here. Here's my first factor, a plus 6. Here's the second factor, which is 3a minus 7. And those are both set equal to 0. So I know if these two things multiplied together equal 0, that means one of them has to equal 0. And if I jump back to our... So basically I'm going to split up these two equations. So I'm going to take this first factor, which is a plus 6. Whoops. And I'm going to say a plus 6 equals 0. Then I'm going to take the other factor, which is 3a minus 7, and I'm going to set that equal to 0. If you look back at our steps, now we have these two mini equations. We need to solve each one. So I'm going to start with a plus 6. To get a by itself, I know I need to subtract 6 from each side. And then I'll get a equals negative 6. So here's the first answer. The second one, I have 3a minus 7. Remember, to solve this, we always have to take care of, we can't touch the term with the variable in it. You always have to do the addition or subtraction stuff first. So we need to start by adding 7 to each side. So we'll get 3a equals 7, and then This is 3 times a, so I need to divide both sides by 3. And you can leave this as a fraction, or you can change it to a decimal, doesn't matter. But a equals 7/3. So really what you guys just figured out, if I take this a equals -6 and I plug it back in, -6 plus 6 is 0. And if this whole thing is 0, that means the whole equation equals 0. Or we figured out another possible solution. If I take this 7/3 and plug it in for a, this factor is going to equal 0, which means this whole equation will equal 0. So we solved the equation. Check out example 2. This time it is not factored for you. And the clue is I don't see any parentheses, kind of like that last example. So think about those steps. The first step was to make sure everything is on the same side. If you notice right here, we have an equal sign in the middle. So I'm going to leave the x squared term right there. That one's positive. I want to keep that positive. So I'm going to take this -21x, and I have to do the opposite to move it to the other side. So I'm going to add 21x to each side. Now remember, these guys have to have the same exponent to be able to combine them. This is an x squared term, and this is just an x to the first. So I can't combine them. I'm just going to write them next to each other. So 14x squared plus 21x. And now equals, on the other side we have 0. Your next step is to factor it. So remember, yesterday we practiced those two different kinds of factoring. Your first question is always to look for a GCF. So I'm going to make a factor tree right here. So 14 I can split up into 7 and 2. 21 I can split up into 3 and 7. So 14x squared, if I list out the prime factorization, is 2 times 7 times x times x. 21x I can rewrite as 3 times 7 times x. Now let's look and see what they have in common. I see a 7 in both, and I see an x in both. Now I'm going to make that box, and it's going to be a 1 by 2 box because I have two terms. We just figured out the GCF is 7x, and that's going to go up front. To figure out what goes on top, we need to go back and look at leftovers. From 14x squared, there's a 2 and an x left over, so 2x. From the 21x, there's a 3 left over. And then I'm going to write the answer, 7x times 2x plus 3. So that whole middle part you guys are familiar with. Remember though, here was our original equation. 14x squared plus 21x equals 0. So I need to keep that equal 0. Now our job, I want to figure out what x has to be to make this whole thing equal to 0. So this is where we're going to take that equation and split it up and set each mini equation equal to 0. So I got a new screen here so we have more space. So I'm going to take this 7x, that's the first factor, and set it equal to 0. And then I'm going to take the second factor, 2x plus 3, and set it equal to 0. I know if this whole equation equals 0, then one of these two factors has to equal 0 to make that true. So let's go through and solve each one. 7 times x equals 0. I need to divide both sides by 7. So x equals 0 would make that equation true. On the other one here, remember always do addition or subtraction first. So subtract 3 from each side. 2x equals -3, and then divide both sides by 2. And again, you can leave it as a fraction or a decimal, doesn't matter. So you could say -3/2 or -1.5. But those are my two answers. So if I took x equals 0 and I plugged that back in up here, 7 times 0 is 0, and then 0 times this is going to get us 0. So both of these answers here make that equation true. We will talk more about why you'd want to solve these later this week. All right, I'm going to pause. I'm going to have you guys pause the video here, and I want you guys to take a couple minutes, look through those steps, look back at the example you just did, and try this one on your own before I show you what to do. All right, talk to you in a minute. Hopefully you guys had a chance to try this and check your answer up here. So when I go back to those steps, the first thing is I need this equation to be equal to 0. So I need to move everything to the same side, leave the x squared term where it is, and let's move this 4x to the other side. Because it's positive, I need to subtract. These are not like terms right here because they don't have the same exponent. So we're not going to put them together, we're just going to write them next to each other. So x squared minus 4x, and now this is equal to 0. Step 2 is we need to factor. So check for a GCF. I notice right away these guys have an x in common. So I'm going to make the factor tree. The x squared term doesn't have a number, but the negative 4 I can break down into negative 1 times 2 times 2. So when I look at these lists, I see that they have an x in common. And now I'm going to make that backwards box. So there's two terms, so I need a 1 by 2 box. The GCF we just figured out was x, that goes out front. Look at leftovers to figure out what goes on top. So right there, there's an x left over. Right here, negative 1 times 2 times 2, there's negative 4 left over. And then write your answer as the product of two things. So x times x minus 4. And then don't forget, the original problem we had that equal 0. Now that we factored it, your next job is to try to solve for x. What does x have to be if this whole equation is equal to 0? So this is the part where we're going to split up. So I'm going to take the first factor and set it equal to 0. And I'm going to take the second factor and set it equal to 0. This one's already solved for. So I know if x equals 0, that'll make the equation true. Over here, though, we have x minus 4 equals 0. We have to add 4 to each side. So either x equals 0 to make this true, or x equals 4. All right, please pause the video here again. You guys try this one, and I'll catch up with you in just a minute. All right, this is very similar to the last one. So first thing I notice is that there's an equal sign in between them. So I want to get everything to the same side. Remember, these are not like terms, so we cannot combine them. Factor these guys. You should figure out that the GCF, 9x is going to be in both of these. And if you weren't sure, you should make the factor trees. So 9x squared, I can split up into 3 times 3. Negative 27x, we can split up into negative 1 times 27. 27 is 9 times 3, and the 9 is 3 times 3. So now when you write out the prime factorizations, you can see what they have in common. So I see 2 3's in common and an x in common. So that's how I knew the GCF was going to be 9x. Let's look at leftovers. So the first term has an x left over. The second term has -1 times 3, so -3 left over. So the first part here, we're going to get 9x times x minus 3. And remember, that was set equal to 0. Our next job is to take each one of those factors and split it up and set each one equal to 0. So the first factor, we're going to say 9x equals 0, or x minus 3 equals 0. And then solve each mini equation. For the first one, we divide both sides by 9, so either x equals 0, or on this other side, we add 3 to both sides, and x equals 3. So we have two possible answers that could make that equation true. All right, you have 2, are you a master? Will you please make sure you change number 2 here? So cross off the one that's there and please rewrite this one. And then I want you guys to try these. We're going to pause the video and I will show you answers in just a second. All right, for the first one, this one you guys didn't have to get the terms to the same side. Everything's already on the same side. When you factor it, the GCF is 2x. The first term, you should have 4x left over, and then -1 equals 0. So you should have made the factor tree, make that backward box, but this is what it's going to look like once it's factored. Then we're going to take each term and split it up. And then solve each mini equation. So the first one, we have to divide both sides by 2, so we figure out x equals 0. The second one, make sure you add first. So we'll get 4x equals 1, and then divide both sides by 4. So either x equals 0 or x equals 1 over 4. By the way, notice for all these you have 2 answers. The second one is already factored here, so we just have to do that last part where we split it up and set it equal to 0. So either y minus 3 equals 0 or y plus 2 equals 0. So for the first one, add 3 to each side. You get y equals 3, or if we solve the second one, you'll get y equals -2. So there's your 2 answers. What you guys are doing right now, please grab the 7.4a homework and work on that. If you finish, then work on anything else in the packet before that that's not done, so 7.1 through 7.3b. And if you're done with that, please read or work on other homework. You may not have your phone out. Have a good day, guys. See you tomorrow.